Hi everyone, welcome back to Vadhyar Online Academy's Technical Mathematics Lecture Series. In this video, we are going to continue with Binomial Theorem. This video is the second one related to Binomial Theorem. So if you haven't watched our first video on Binomial Theorem discussing basics, then I recommend you to watch Lecture 7, Binomial Theorem Part 1, and then come back to this video. In Lecture 7, we discussed basics of Binomial Theorem, and in this video, we will discuss about identities of binomial theorem, the greatest coefficient, and properties of binomial coefficients. Let's start our discussion with identities of binomial theorem. The first identity says a minus b whole raised to n is equal to a raised to n minus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2 minus etc. plus minus 1 raised to r minus 1 nc r minus 1 into a raised to n minus r minus 1 into b raised to r minus 1 plus etc. plus minus 1 raised to n into b raised to n. Now here this expansion is similar to that of a plus b whole raised to n. The only difference is that here on left hand side we are having a minus sign in place of plus sign, and on right hand side we are having alternate minus signs coming up. The first term here is positive, the second term is negative, again third term is positive, but fourth term is negative. So this way minus sign comes up alternately, and this expansion will also have n plus 1 terms, and the rth term in the expansion will be minus 1 raised to r minus 1 into nc r minus 1 into a raised to n minus r minus 1 into b raised to r minus 1. Okay. Now the second identity says 1 plus b whole raised to n is equal to 1 plus nc1 into b plus nc2 into b square plus etc. plus nc r minus 1 b raised to r minus 1 plus etc. plus b raised to n. So this identity is derived by replacing a with 1 in the expansion a plus b whole raised to n. Okay, now the third identity says 1 minus b whole raised to n is equal to 1 minus nc1b plus nc2b square minus etc. plus the rth term plus etc. plus minus 1 raised to n into b raised to n. So this identity is obtained by replacing a with 1 in the expansion a minus b whole raised to n. Okay, now if b is equal to 1, then identity 2 becomes, if you substitute b equal to 1 in identity 2, that is here, what we get on left hand side will be 1 plus 1, that is 2 raised to n. So on left hand side we will get 2 raised to n equal to, if you replace b with 1 on right hand side, what we get will be 1 plus nc1 plus nc2 plus etc. plus 1. Okay, so the first one at the beginning, okay, we can replace that with nc0. Then the next coefficient will be nc1 plus the next coefficient will be nc2 plus etc. plus finally at the end we will have a 1. Okay, that one may be written as ncn. So we are getting a very important identity here. nc0 plus nc1 plus nc2 plus etc. plus ncn will be equal to 2 raised to n. So that means the sum of binomial coefficient will be equal to 2 raised to n. So it's a very important identity. Okay, now if b is equal to 1 in identity 3, so if we substitute b equal to 1 here, then what we get on left hand side will be 0. 1 minus 1, 0 raised to n, that is 0. So LHS will reduce to 0. Right hand side we have 1 minus nc1. Okay, if you substitute b equal to 1, what we get here will be nc1 plus nc2. If you substitute b equal to 1 here, you will be getting 1 square, that is 1. So nc2 minus etc. plus the rth term plus etc. minus 1 raised to n into 1 raised to n. So if we replace b with 1, what we get here will be 1 raised to n, that is 1. So we may rewrite identity 3 as 0 equal to nc0 minus nc1 plus nc2 minus etc. plus minus 1 raised to n into ncn. So at the beginning as well as at the end we will be having a 1. So the 1 at the beginning may be written as nc0, and here we have minus 1 raised to n into 1. Okay, so that one here, this will reduce to 1 if you substitute b equal to 1. So minus 1 raised to n into 1, that one may be replaced with ncn. Okay, so what we are getting if we substitute b equal to 1 in identity 3 is nothing but this one. Okay, nc0 minus nc1 plus nc2 minus etc plus minus 1 raised to n into ncn will be equal to 0. Okay, now let's see one problem. Problem number 1. The term containing x raised to 8 in the expansion of 2x minus 1 by 2x whole raised to 20 is. Okay, so we are given 4 options here. We have to find out the right one. So here, to find out the term containing x raised to 8, we have to consider the rth term. So here the rth term in the expansion will be 20c r minus 1 2x raised to 20 minus r minus 1 into 1 by 2x whole raised to r minus 1. Okay, now let's separate constant terms and x terms. We will combine constant terms together. That will be 20c r minus 1 2 raised to 20 minus r minus 1 into, here we have 1 by 2 raised to r minus 1. So 1 by 2 raised to r minus 1. So this complete term will be the constant here. Okay, so we will take it as k. Okay, so k into, here we have x raised to 20 minus r minus 1. So that we will write as such, x raised to 20 minus r minus 1. Okay, that into, here we have 1 by x raised to r minus 1. So 1 by x we will write as x raised to minus 1 whole raised to r minus 1. Okay, so we may rewrite this as k into x raised to 20 minus r minus 1 into, here we have x raised to minus 1 whole raised to r minus 1. So that can be written as x raised to minus r minus 1. Okay, now let's combine these two x terms. So once we combine those two, what we get will be k into x raised to 20 minus, here we have 20 minus r minus 1, here we have minus of r minus 1. So when you combine these two, what you get will be 20 minus 2 into r minus 1. Okay, so this is the rth term in the expansion. Okay, now the term that we have to identify is having x raised to 8. Okay, so the exponential factor corresponding to x is 8. So the term containing x raised to 8 will have 20 minus 2 into r minus 1. Okay, so here in general expression, the power of x is 20 minus 2 into r minus 1. So when you substitute that to 8, we will get the term which is containing x raised to 8. Okay, so the r value, whatever we can calculate, will be that term which contains x raised to 8. Okay, so here the power of x is 20 minus 2 into r minus 1. We have to substitute that equal to 8. Okay, so the value of r will give us the value of the term containing x raised to 8. Okay, now once we simplify this, what you get is, take this 8 to the left hand side, take this 2 into r minus 1 to the right hand side. What we get is 20 minus 8 equal to 2 into r minus 1. Okay, now that gives us 12 equal to 2 into r minus 1. This implies that, okay, when you cancel 2 from both left hand side and right hand side, on left hand side you will get 6. So 6 equal to r minus 1, or this implies r is equal to 7. So it will be the 7th term that contains x raised to 8. Okay, so here the right answer is option C. Now problem number 2. The number of terms in the expansion of x square minus 2 by x square whole raised to 5 is. Okay, so this expression is in the form a minus b whole raised to n. So for a minus b whole raised to n, the number of terms will be n plus 1. So here in place of n we have 5, and therefore here answer will be 5 plus 1, that is 6. So this expansion will have 6 terms. So here the right answer is given by option B. Now let's see what is the greatest coefficient. If n is even, the greatest coefficient in the expansion of a plus b whole raised to n is n by 2. Okay. And if n is odd, then there are two greatest coefficients in the expansion of a plus b whole raised to n, and they are nc n minus 1 by 2 and nc n plus 1 by 2. So we are having two greatest coefficients when n is odd. Okay, now let's see one problem related to this. Problem 3. The greatest coefficient in the expansion of 1 plus x whole raised to 2n plus 4 is. So here in place of n, what we have is 2n plus 4. This n can be anything. N can be anywhere between 1 to infinity. So 2n plus 4 will be definitely an even number. 2n plus 4 will be an even number. Here we are multiplying n with 2, that itself is an even number, then that is added with 4. So definitely this term 2n plus 4 will result in an even number. Okay, so therefore here greatest term will be given by the modification of nc by 2. If the expression has a power of n, then the greatest coefficient will be equal to nc by 2 if n is even. So here n is even, but in place of n what we have is 2n plus 4. So therefore this implies that in this case, in this expansion, the greatest coefficient will be 2n plus 4 c 2n plus 4 by 2. Okay, so once you simplify this, what we get is 2n plus 4 c n plus 2. Okay, so this will be the greatest coefficient in the expansion 1 plus x whole raised to 2n plus 4. So here the right answer is given by option B, 2n plus 4 c n plus 2. Now let's discuss about properties of binomial coefficients. The first property says nc0 plus nc1 plus nc2 plus etc. plus ncn is equal to 2 raised to n. So we discussed this point while we were discussing identities of binomial theorem. So this property of binomial coefficients says that sum of all binomial coefficients will be equal to 2 raised to n. So this left hand side will be nothing but sum of binomial coefficients. Okay, so that will add up to 2 raised to n. Now the second property says nc0 minus nc1 plus nc2 minus etc. plus minus 1 raised to n ncn will be equal to 0. Okay, now the third property says nc0 plus nc2 plus nc4 plus etc. plus ncn will be equal to 2 raised to n minus 1. And the fourth property says nc1 plus nc3 plus nc5 plus etc. plus ncn will be equal to 2 raised to n minus 1. Okay, so properties 3 and 4 says alternate binomial coefficients. If we add those, we will be getting a value which will be equal to 2 raised to n minus 1. Okay, now let's move on to property number 5. If a0, a1, a2, etc. an are in arithmetic progression, then a0 into nc0 plus a1 into nc1 plus a2 into nc2 plus etc. an ncn will be equal to a0 plus an into 2 raised to n minus 1. Okay, now the sixth property says if three consecutive binomial coefficients ncr minus 1, ncr and ncr plus 1 are in arithmetic progression, then r value will be equal to 1 by 2 into n plus root over n plus 2. Okay. Property number 7. Coefficient of b raised to n in the expansion 1 plus b whole raised to 2n is 2 into coefficient of b raised to n in 1 plus b whole raised to 2n minus 1. Okay. Now the property number 8 says coefficient of 1 by x in the expansion of 1 plus x whole raised to n into 1 plus 1 by x whole raised to n is equal to 2n factorial divided by n minus 1 factorial into n plus 1 factorial. Okay, so with this we are coming to end of properties of binomial coefficients. We discussed 8 properties related to binomial coefficients. Now let's see few problems related to this. Problem 4. If p and q are coefficients of x raised to n in the expansion of 1 plus x whole raised to 2n and 1 plus x whole raised to 2n minus 1, then p equal to q. Option B says p equal to 2q. Option C says 2p is equal to q, and option D says p plus q is equal to 0. Okay, so this question is based on property number 7 of binomial coefficients. Property number 7 says coefficient of b raised to n in the expansion 1 plus b whole raised to 2n is 2 into coefficient of b raised to n in the expansion 1 plus b whole raised to 2n minus 1. Okay, so here we are asked to calculate coefficients of x raised to n in the expansion of 1 plus x whole raised to 2n and 1 plus x whole raised to 2n minus 1, and we are asked to find out the right relation between those two coefficients. Okay, so here answer will be p equal to 2q. The coefficient of x raised to n in the expansion 1 plus x whole raised to 2n is p. That will be 2 times that of the coefficient of x raised to n in the expansion 1 plus x whole raised to 2n minus 1. So this is based on property number 7 of binomial coefficients. Now let's see another problem. Problem 5. The coefficient of 1 by x in expansion of 1 plus x whole raised to n into 1 plus 1 by x whole raised to n is. Okay, so this question is also based on properties of coefficients. So that is based on property number 8. Coefficient of 1 by x in the expansion of 1 plus x whole raised to n into 1 plus 1 by x whole raised to n is equal to 2n factorial divided by n minus 1 factorial into n plus 1 factorial. Now when you check the options, we do not have that expression here. So we will have to check which one of these 4 gives us the value equal to 2n factorial divided by n plus 1 factorial into n minus 1 factorial. Okay, so here if you expand the term given in option B, what you get is 2n factorial divided by 2n minus n minus 1 factorial into n minus 1 factorial. So once you simplify this, you will get it as 2n factorial divided by 2n minus n, that will give us plus n, then we have minus of minus 1, so we will get it as n plus 1 factorial into, here we have n minus 1 factorial, n minus 1 factorial. Okay, so here the right answer is given by option B. Okay, now with this we are coming to end of lecture 8. In lecture 9 we will continue with binomial theorem. We will discuss important questions from the topic binomial theorem. So for upcoming videos you may subscribe to our channel Vadhyar Online Academy on YouTube, and for study materials please subscribe to our Telegram channel using this link. So see you in lecture 9. Goodbye.